Hello everyone. Today I will present our paper, Rethinking Minimal Sufficient Representation in Contrastive Learning. Contrastive learning is an outstanding self-supervised representation learning framework, and there are many classic works like Moco, SimCLR, and BLOL. From the above classic works, we can find the internal mechanism of contrastive learning. The views provide supervision information to each other. So we can treat V2 as the supervision signal for V1, just like the label Y in the supervised learning. Based on this new perspective, we can define the sufficient representation and the minimal sufficient representation in contrastive learning, just like in the supervised learning. The sufficient representation contains all shared information between views, but may also contain other information from the input. The minimal sufficient representation only contains the shared information between views. Contrastive learning maximizes the mutual information between the representations, and it is upbounded by the mutual information between views. So when the encoding functions have enough capacity and are well learned based on sufficient data, we can assume contrastive learning obtains the sufficient representation. On the other hand, the sufficient information of one view only comes from the other view, so we can assume the representations learned in contrastive learning are approximately minimal. Now let's consider an important question. Is the minimal sufficient representation really better for contrastive learning? The answer is no, or more precisely, it is not true for transfer performance. We can strictly prove that the minimal sufficient representation contains less task-relevant information than other sufficient representations. Generally, the more task-relevant information contained in the representations, the better performance can be obtained. For downstream classification tasks, we can strictly prove the upper bound of the base error rate for the sufficient representation is smaller than that for the minimal sufficient representation. From downstream regression tasks, we can strictly prove that the sufficient representation can achieve lower expected squared prediction error than the minimal sufficient representation. From the above analysis, we found contrastive learning has a risk of overfitting to the shared information between views. So how to alleviate this problem? We propose to increase the mutual information between the representation and the input, because the increased information from input may be relevant to some downstream tasks. To this end, we consider two implementations to achieve it. The first one is to reconstruct the input from the representations. This is more intuitive and performs better. The second one is to use the inflation lower bound estimate. This only needs the representation level calculation and have broad applicability. Our method introduces more non-shared information and improves the performance on various downstream tasks, especially on transfer tasks, and it is widely applicable to different contrastive learning models. Some previous works propose to learn the minimal sufficient representation, but the method does not make much change to the performance, which means the sufficient representation learned in contrastive learning is already approximately minimal. Increasing IZV consistently improves the performance, but we should not excessively increase it, which may introduce noise besides useful information. When training with more outputs, the transfer performance continues to degrade, which means the contrastive learning models overfit to the shared information between views. Increasing IZV can effectively alleviate this problem. According to the above analogy, our method can also alleviate the overfitting on the label information and improve transfer performance in the supervised learning. This discovery may help to obtain more general representations in the field of supervised pre-training.